For this example, we're going to use the law of sines to solve this triangle. So we have angle A is 105 degrees, side A is 73, and side B is 55. So the side opposite our given angle and then the adjacent side. So this ends up being a side angle side triangle. If you draw the triangle, it will look something like this. So here we have angle A at 105 degrees. The side opposite it is 73. Angle B here with side opposite it being 55. So this is an obtuse triangle, and we know that side BC, or side A, the side opposite our given angle, is greater than our adjacent side. So this does in fact make a triangle. So let's go ahead and solve this using the law of sines. So we're going to solve for angle B first. So using the law of sines, we have this. We have an angle side pair here with 105 and 73, right? So we can use law of sines. So it says the sine of 105 degrees divided by 73 equals the sine of B, angle B, divided by 55. Again, and this is a side-side angle triangle because it's two sides in the non-included angle. So we can find angle B by multiplying by 55. So we have the sine of B equals 55 times the sine of 105 degrees. All of this divided by 73. And then we're going to take the inverse sine of all of this to get the measure of angle B. The measure of angle B is equal to the inverse sine of all of this stuff. So you take all of this, plug it into your calculator, and we're going to get that the measure of angle B is about, let's round to the nearest tenth. We're going to get about 46.7 degrees. So this measure here is about 46.7 degrees. Now let's find the measure of angle C. So we can find the measure of angle C by taking the sum of 105 and 46.7 and taking that sum and subtracting it from 180 degrees. So the measure of angle C is equal to 180 minus the sum of our other two angles, 105 plus 46.7. And that gives us that the measure of angle C is, what is that, 28.3 degrees. So this is 28.3 degrees. And the last thing we need to find is side C, and then we'll be done solving this triangle. So to find side C, we're going to use law of sines. Again, we're going to use our original angle side pair because it's the one that's most accurate. So we have the sine of 105 degrees divided by 73 equals the sine of 28.3 degrees divided by C. So take the cross product, and that gives us C times the sine of 105 degrees equals 73 times the sine of 28.3, and then divide by the sine of 105 degrees. And we get that C is about 35.8 units. So let's again round to the nearest tenth. So 35.8 units. And there we've solved our triangle.